All right, welcome to the rat dissection. So rats are in kingdom Animalia. They are also chordates, they are vertebrates, and they are also mammals. So we see a lot of the evolution of organ structures come full circle here in the rat, and we're able to see some similarities in those organ structures that we see in us humans as well. So, looking at our external features of the rat, we have two different cavities. We have the thoracic cavity and the abdominal cavity. The thoracic cavity consists of the head and the neck, and the abdominal cavity consists of the trunk and then the tail. Looking at our tail, the rat's tail basically is used for balance and to help them walk in narrow passages, and it also helps with the sense of their surroundings. And this is actually quite different from the caudal fin in the perch, where that caudal fin moved left to right, side to side, and provided a forward thrust for locomotion so that the fish can swim. Whereas the rat, their tail kind of moves in any direction, and it's used for that balance. So, looking at the internal features of the rat, before we do that, we're going to look at the reproductive structure. And right here we have what is clearly a male. We have the scrotum, we have a penis right in this area, and then the anus is tucked right in between the tail and the scrotum. So we know our rat is a male. Continuing on and looking at some of the muscle structures, we weren't able to look at too many muscle systems, but to kind of show a few, we have our external oblique muscle, which is basically just the abdomen, and that is used for supporting that trunk as well as holding all of the organs in place. We also know that the rat has two different forms of muscles to help in locomotion. They have the cutaneous maximus and the biceps femoralis, which are basically our biceps and triceps. And these muscles are paired and they produce opposite actions. So as one goes one way, the other goes the other, and this helps that locomotion for rats. So, continuing on into the body cavity, we have obviously our thoracic cavity, which consists of everything from the liver above. So this could include our heart, our esophagus, our trachea, our mouth, all those things. And then the abdominal cavity houses everything else from the stomachs to the intestine to the lungs, and even the reproductive structures. And so looking at this, we know that when we dissected the perch, we had basically a pericardial cavity up here for the perch, and then in the posterior end we had the peritoneal cavity. And they're pretty much the same. The pericardial cavity and the thoracic cavity are located towards the anterior end, and they house the heart. The abdominal cavity and the peritoneal cavity are located posterior of the perch and the rat, and holds basically the rest of the organs. So, digging deeper into the internal features, we're looking at the digestive system. Rats have a complete digestive system, so meaning that they have a mouth for an opening and an anus as an exit. And so basically looking at this, we have the food will go into the mouth, past the pharynx or the larynx, and then through the esophagus, and then it'll end up in our stomach. And so from there, liver produces bile, and the gallbladder stores that bile, and that helps in the digestion process. And as that food tends to pass into the small intestine, large intestine, gets mixed with juices from the pancreas, enzymes that help with digestion as well, and eventually out the anus to complete the digestive system. And so this is similar to the crayfish, in which they both had that complete digestive system with the stomach, the intestines, and even the bile-producing glands. But the only difference between the rat and the crayfish is that they perform mechanical digestion in different locations. The crayfish will actually use their mechanical digestion inside using their gastric mill with their gastric teeth. But our rat uses its mouth to chew food with its teeth to send down past the pharynx and the esophagus into the stomach. So continuing on, we have our respiratory system. Our respiratory system consists of our mouth and our nasal structure, our larynx, and then the trachea and the lungs. And the lungs are actually hidden behind these, behind the liver. But knowing kind of where they are located, we know that the air enters through the mouth/nasal structure, and then it passes the larynx into the trachea, and then finally into the lungs, where it breaks up into different compartments, basically, where we have the bronchi, the bronchioles, the alveoli, and the alveoli basically runs down and then into the capillaries that supply the oxygen to the blood. Rats do not diffuse oxygen through their skin because they have that fur coat lining, and that's because that was an evolutionary trait that allowed them to live in terrestrial environments. And that also kind of helps them stop from drying out, unlike the earthworm, who diffuses oxygen and uses that moist skin to provide nutrients to its bloodstream. And so because rats are able to live in those terrestrial environments, unlike earthworms, they have those specialized organ structures, the lungs, that allow them to respirate and provide oxygen to that bloodstream. So, looking at our urinary and our reproductive system, we have our urinary bladder right here, which is basically connected to our kidneys right above here. And that system basically starts at the kidneys and connects to arteries and veins, which connects to the urinary bladder and down to the urethra, which would then allow for the rat to urinate. And so looking at this urinary system, it's actually a lot different from the crayfish, in which the crayfish really only possess like this simple intestinal gland that allows them to excrete waste. And then the rat has this complex system starting at the kidneys. We also look at the reproductive structure to verify that it is a male. We have our penis, which actually kind of got cut up, but that is visible. And then we have our scrotum, which digging into it, we have our testicle with the epididymis, and then our vas deferens, which is connected to that. Continuing on, we have our circulatory system. And so this is important. Rats have a 4-chamber heart, and it's the first time we see this in mammals. And so they have this closed circulatory system that's similar to the perch's closed circulatory system, where blood is transported directly to organs, but the perch heart only consists of 2 chambers, whereas the rat has the 4 chambers. And so rats have this, they utilize this thing called double circulation because they have that 4-chamber heart, and they basically use that double circulation to circulate oxygen-rich blood and oxygen-poor blood away from and to the heart. So looking at this, we have the systemic circuit, which flows down to the body, and basically that blood flows into the arteries that takes blood away from the heart into smaller artery channels, and then finally into the capillaries. And so once the blood is provided to those organs for nutrients and all that, the blood is then sent back to small vein compartments and then into actual veins, which lead the blood back to the heart. And so once that poor oxygenated blood is in the heart, it circulates and eventually picks up oxygen from the lungs and gets rid of that CO2. So, looking at that, we have our rat, we have all the systems, and yeah.